All right, slope fields. This is section 9.2 in the Stewart Calculus book, and we're going to talk about slope fields. So this is called a differential equation. Why is it called a differential equation? Because the dy dx is a derivative and it's an equation, so it's a differential equation. Differential equation. All right, now we're going to make a picture of this differential equation, and the picture of this differential equation is called a slope field. And we're also going to algebraically solve differential equations. Now, differential equations are a whole topic in mathematics. You can have differential equations that are linear. You can have differential equations that are nonlinear. You have first degree, second degree, all kinds of different kinds of differential equations. And they're very useful in different applications in math and science. So we're going to make a picture of this. You have to understand that there's one input here. There's the first input for x, and then there's a second input for y. And then, so you put in an x and you put in a y, and then you get out something. You get back out a dy dx. Well, what is dy dx? dy dx is slope. So you get out a slope. So you make little baby slopes. Make a field of slopes. So here we go. I'm going to put in 1 for x. I'm going to put in 0 for y. I'm going to put 1 in for x and 0 in for y. And so what's that going to give me back? Well, 1 minus 0 gives me 1. So if I'm keeping track here, I'm putting in an x and a y, and I'm getting out a dy dx. So I'm putting in 1 and 0, and I'm getting back 1. So what you do is you go to the point 1, 0 on the xy axis, which would be right there. That's 1, 0, and you make a slope of 1. So you make a little baby slope. All right. The next point that I'm going to put in is 1, 1. So if you put in 1 here and 1 there, well, that'd be 1 minus 1. 1 squared is 1, so 1 minus 1 is 0. So if you go to the point 1 over 1 up, right, that point right there, then the slope is 0. All right, oops, there's the slope of 0. Let me make this a little bit bigger so I don't get off there. Let's see, refocus. All right, so now you can see the equation, the table, and the picture all in one shot. All right, let me do a little peekaboo here. 2, 0. So I'm going to put in 2, 0. So that would be 2 minus 0 would be 2. So then as we go to 2, 0, then it's going to be a steeper slope. So as we move this way, it's going to be a steeper slope. All right, next point that I'm going to put in is 0, 1. 0, 1, 0, 1. So you put in 0 and then 1 there. It'd be 0 minus 1, so it'd be negative 1. So 0, 1 is right here, and it's going to be a negative 1 slope. All right, and then we can just kind of keep doing this forever. What about 2, 2? So 2, 2, 2, 2. So if I put in 2 and then 2 there, that would be 2 minus 4, which would be negative 2. So when I go to 2, 2, it's going to be a negative 2 slope. So there's 2 and 2. And what about 0, 2? 0, 2 would be a slope of negative 4, so it's going to be really steep there. So as you go up this way, it's going to get really steep because you're squaring that negative number. All right, and what about 1, 2? 1, 2 would be negative 3, so it's going to be kind of negative up in here. All right, well, this goes for all around the whole xy axis. So there's going to be little baby slopes everywhere. So here's what this looks like if you keep doing this, like putting in xy points and creating a slope field. So here it is. So one of the points that I put in was, I didn't even put 0, 0 in, but 0, 0 would be 0. Right, and then we said 1, 0 would have a baby slope of 1, and then 2, 0 would have a slope, little baby slope of 2. So we create all these little baby slopes. All right, now one of the things you have to do is you have to kind of create one of these. All right, one of the things, the next thing we need to talk about is the Euler path. So there's the equation right there. and then the Euler path. This is one Euler path. Now here's my analogy for this. You've all been out and around streams in the countryside in Ohio, and sometimes if you watch like things float down the stream, they get hung up by a rock, and sometimes they go faster in some places and slower than other places. Well, that's kind of what this is like the how something would travel down the stream, and this would cause like the direction of travel that it would be. So if you dropped a stick right here, it would follow this path. It would follow the slopes. Well, that's one of the solutions, because when you take the antiderivative of this, there's always that plus c. So if you take the antiderivative of this, you get that plus c. So you really don't know where the exact solution is. This is kind of a picture of all the solutions. So if we had an initial condition, which means if we drop the floating stick right here, then it would go like that. If we drop the floating stick over here, we go maybe like that. If we drop the stick in right here, it would come down here and go like that. So there's infinitely many solutions here. There's infinitely many places where you could drop the stick and watch it float down the stream. But the little baby slopes give us a direction of travel for that stick. So this is called a slope field. It's a field of slopes. And how do we generate all the little baby slopes? We put an x and a y in here, and then we come out a slope. So you put in an x, you put in a y, do the calculation, you get out a slope. And you graph all the little baby slopes, and it makes a slope field. All right, so that's a specific example, and there's the picture for it. What's the next thing that we're going to do here? All right, let's go ahead and do this one. Now, this one here is pretty simple because I've eliminated y. There's no y value here, so y could be anything. It's all dependent upon x. So if x is 1, the slope is 1. So see right here? X is 1, so the slope is going to be, no. If x is 1, the slope is going to be 2. In fact, you know what you could do is you could call this a half if you wanted to. So you could say this is 1/2, and this is 1, and this is 1 1/2, and then this is 2, right? You could make more things in there. So if x was a half, then you would get a slope of 1. Let's do that. So there's my slope of 1, 45 degrees, right? So x is a half, 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 right? What if x was 0? If you were putting x was 0 in here, well, then all the slopes would be 0. So x is 0 right here. All right, and then 1, if you put 1 in there, and then you get 2, so that'd be a steeper slope, right? Steeper slope, steeper slope, steeper slope, steeper slope, steeper slope. And then 1.5 is going to be 3, right? It's even steeper. Okay, so there's all the slopes there. Now, if we go to the other side, if we put in -1 or -1/2, let's do -1/2, then the slope would be -1. So we get a -1 slope on all these. So this is a lot easier because you're just putting in x. So like we put in x is -1/2. Well, you put in -1/2, it's 2 times -1/2, it's going to be a slope of -1. Then we put in -1, so it's going to be a slope of -2. -2, boom, 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 ba, 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 ba. And it just keeps getting steeper as we move out this way, right? Well, now, if you kind of look at this, the Euler path is you can kind of see it, right? If I dropped my stick in right here, what would it do? Whoop, like that. And what does that look like? That looks like x squared, doesn't it? It looks like a parabola. Well, what's the antiderivative of 2x? The antiderivative of 2x is indeed x squared, but it's x squared plus c, right? So the antiderivative of this is x squared plus c. So we don't know the initial condition, so we have infinitely many opportunities to draw Euler paths here. What if c was -1? Then we would go like that. What if c was a positive number? Then the Euler path would be like this, or like this, or like this. You know, it's all up and down. There's infinitely many Euler paths here. Okay, so that one here, y doesn't matter, right? So x is the thing that's changing. So y doesn't matter. So as you go up and down, it's always the same. But left and right, it changes because it's changing based on an x value. Okay, so this one here is x plus y squared. So there we go. So this one's kind of like the very first one, except for it's plus instead of minus. So 0, 0 would be 0, so you put a little flat line there. 1, 1 would be 2, right? Slope of 2. 1, 0 would be 1, right? 2, 0 would be 2. 3, 0 would be 3, right? It's getting steeper that way. Negative 1, 0 would be negative 1, negative 2, negative 3. So as you put in more and more numbers this way, right? But it's changing left and right, and it's going to change up and down because it's a y value too. So there's 1, 1 was 2. 2, 1 would be 3, right? Because you put 2 there and 1 there. So 2, 1 is 3. 3, 1 would be 4. So it's getting steeper there. 1, 3. 1, 3 would be really steep. It'd be 9, wouldn't it? Oh no, that's 1, 2. That'd be 4. 2, 2 over 2 over 2 up to 2, 2 would be 6. Yeah, 6, because it'd be a 2 there and a 2 there. That'd be 6. 3, 2 would be 7. All right, and then you can put some negatives in here. Negative 1, 1. Negative 1, 1 would be, whoa, negative 1, 1 would be 0, wouldn't it? Be flat there, wouldn't it? Yeah, negative 1, 1 would be 0. Negative 1, 2. Negative 1 up 2 would be positive 3. Whoops, positive 3. Negative 1, 3 would be positive. Yeah, negative 1, 1 is 0, right? Yes. I've made a couple of YouTube videos today. Yeah, negative 1, 1 would be 0. Oh. Okay. And so then negative 2, 1 would be negative 1. Okay. And negative 2 would be 2. All right, because it would be negative 2 plus 4. Negative 3, 1. Negative 3, comma 1 would be negative 2. Negative 3, 2 would be 1. So there kind of is. Oh, we didn't do 0, 1 would be 1. 0, 2 would be 4. Okay, so there it is right there, and then you just kind of fill these in too. Now you don't have to fill out the whole thing. That's what computers are for, but it's to get you to understand the concept here. All right, so here is the assignment. The assignment is on page 592, and I'm going to work through a bunch of these. We'll just do them together, okay? Because this is our new normal right now. All right, so now we're just drawing the different slope fields. It says a directional field for the differential equation x cosine pi y is shown. Sketch the graphs of solutions that satisfy the given initial conditions. So you can kind of see how this is periodic. It has the cosine in it, so it's going to be periodic. So 0, 0. So if 0, 0 is here, right? So it's going to go whoop, whoop, and then 0, 1/2. So if it's right there, wouldn't it just kind of just go straight across? So you just draw those on your own paper. Just make a sketch of it. See 0, 1. Ooh, it's going to go whoop. And then 0, 1.6 would be right about there. So it's going to go whoop. Okay, so there we go. That's kind of cool. 2a, do the same thing. Just draw in, just draw them in. It's like throwing a stick in the water and just make the curved paths there. All right, now matching. So we're going to match these up here, 3, 4, 5, and 6. So the equation and the slope field is here. Plus I have another worksheet of matching that we can do together to make sure you really understand this. All right, now, this one here appears, this one here is the periodic one, right? So which one looks periodic with sines and cosine, or sines in it? I believe it's this one, because how it moves like that. Then this one here only is affecting the y. The y is changing, so x doesn't matter. So left and right it should be the same, but up and down it should change. So I believe that's this one here. Well, that makes sense, because if we put 2 in here, 2 minus 2 is 0. So at 2 the slope, so at y equals 2, the slope is going to be 0 all the way across, and that's no, it could be that one. Okay. Then what if y was 0? Then the slope would be 2. So if y was 0, then the slope would be 2 all the way across. So if y is 0, the slope is 2 all the way across. And that's not it. So this is 3. This is number 3. Okay. Then this one here is adding x and y and then subtracting 1. So let's see. So it'd be like 2. So if we did 2 minus 1, it'd be 0. So 2 negative 1 should be 0. 2 negative 1 should be 0. 2 minus 1 should be 0. So it seems like it's this one here. So if I did 2 negative 1, alright, so this should be number 5. Alright, let me pause it here for a second. Alright, my mind's starting to play tricks on me. So 6 is definitely 2. Oh, this is 6, number 6. 6 is definitely 2. So how do I know that? The sign of 0 and so 0, 0 would be 0. And then all the way across, the sign of 0 would be 0. Plus it has the whole periodic feature to it. So then number 4 must be 1. So could we check that out? Okay, so if I put in 2 right there, so 2 minus 2 is 0. So if y is 2, then it'd be 0 all the way across. So that definitely matches with that. So that's number 4. Okay, so it's 4, 6, 3, and 5. Continuing on here and checking these out. What's the next problem we're supposed to do? Sketch the slope field. So I asked you to look at um, 11, 12, and 13. Okay, so that's the last ones. 11, 12, and 13. So basically, sketch the directional field of the differential equation, then use a sketch to use it to sketch the solution curve that passes through the given point. All right, so just make a few points here. let's do number 12. So we got y dy dx, y prime is dy dx is equal to xy minus x squared. And then we're going to draw in the Euler curve. All right. So 0, 0 would be 0, right? So 0, 0 is going to be a flat thing there. Because if you put 0 there and 0 there. Okay. Now 0, 1. So y is 1 is still going to be 0, isn't it? 0, 2 is still going to be 0, isn't it? Okay. So anywhere x is 0, it's going to be 0, isn't it? Because that's going to cancel that out, so it doesn't matter, then that would be 0. Okay, so now we're going to go here, which is 1, 0. 1, 0 is going to be 0, isn't it? 2, 0? No, that's wrong. 1, 0 would be negative 1. All right, I'm starting to get a little bit the humdrum here or something like that. So 2, 0 would be right here. So 2, 0 would definitely be 0 there, and then be negative 4. So it's really steep right there. Okay, so I'm basically going to fill these points in right here as best I can. So some graph paper would be handy. Okay, so I filled in all these, right? And then I got those. And then 1, 1. 1, 1 would be 1 minus 1. That's going to be 0, isn't it? So 1, 1 should be 0, because that would be 1 and then 1. Okay, 1, 1, 2. 1, 2. And then minus 1 squared. That'd be 1, right? Yes. 1, 2. 2, 2 would be 2, 2 minus 4. That'd be 0. 2, 2 should be 2, 2 should be 0, right? Yep. 1, 1 is 0. Oh, it's 2, 2. I can't count. That's 2, 2, 0. What about 2, 1? It'd be 2 minus 4 would be negative 2. Yeah, it'd be negative 2 right there. So this is turning into a hot mess. Anyway, you get the idea. You put in XY coordinates, and then I'm trying to go too fast, and I'm also really tired because I'm mentally tired because I've been doing these videos to make up for different classes. So anyway, you go through and you do that. Basically, just make a few sketches around here. You don't have to do a whole bunch. And then for this one, the Euler curve, it should come like down like so, and then like that. It kind of comes through like so. If you get all the little slopey babies on there. Now I want to draw your attention to the next part of this, which is doing more of these matching questions. So here's more matching questions. Basically, you have 6 things here, and you have 6 equations over here. So you want to match them up. And there's 6 on the front, 6 on the back. So why don't you go ahead and try those, and then see if you can get them right. And that way you kind of understand the concept here. It's more the slope field is the concept, because then we're going to do the algebra part of the slope field next. Okay, here we go with the answers. Hopefully you've tried these, legitimately tried them, and we're going to start with this side right here. Okay, 35 should be C. So it's just based on X. So C based on X. So X is 0, X is 0, X is 1, X is 2, X is 3, X is negatives. So there we go with that. That makes sense. 37 is A. 37 is A. So you're subtracting X and Y. So every time X and Y are the same, it should be 0. So X and Y are the same. There's X and Y are the same. So like 1, 1. That doesn't look like 0. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. Hmm. 36 is E. 36E is, it's kind of like this one here. It's based on Y. So Y is 0, so it's 0, Y is 1, Y is 2, Y is 3, Y is 4, so the slopes all line up. Y is -1, they all line up there. Okay, and then Y minus X. So this one here is D. So it's Y minus X is 0. So that's going to be the same thing. Oh, okay, so those are the same. They're just flipped from each other. And then the same thing with these two here. 39 is B. 39 is B. So if you divide by 0, then it doesn't exist there. And then the same thing's true on this one here. If Y is 0, so if Y is 0, it's going to be infinitely steep right along there. So it's that one. So that's going to be F. All right, so those are the answers for that side. Okay, now flip to the other side. I gave you a little table here so you could kind of see that. Alright, so for this one here we get 6 of them again. There's the sine one again. That's the periodic one. So I believe that's this one over here, F. So the 3 is F. 1 over X. So X is 0 would be a problem. That'd be straight up and down. So would that'd be A right here. And then as X gets bigger, then it gets flatter each way, positive and negative. So that's A. That one's done. B is the same thing, but it's Y. So it's going to be this one right here. This is B. Okay, and then this one here is exponential. So as you exponential decay-ish. So that one is right here. Yeah, if X is a really big number, then it's going to be really close to 0 either direction. And if X is 1, then it's going to be, or X is 0, that would be 1. So it's going to be this one right there. So that's C. Okay, and then this one here, we're squaring Y, and X has nothing to do with it, it's only Y. So if Y is 0, it's going to be -1. So that would be right here. If Y is 0, it's -1 all the way across. And then left and right, it's the same because X has no effect on it. It's just when you move up and down, it changes. So that would be D. And then this one here is just really cool because it looks like something from Pirates of the Caribbean when they get the big whirlpool thing. So this picture here makes the whirlpool because it's kind of going, and there's the sinkhole in the middle. So that's E. So there we go. It's E, D, F, A, and C, and B. All right. Peace out.